All right, so, Landon, you here? That's why I started. Landon. So, something that I think got sort of missed last week. The chapter 4 follow-up was homework for one of the nights last week. Like, you didn't have a new, worksheet homework. And it was due as soon as you could turn it in. It's in MAP now. I'm not sure if I put it in MAP now, but it's going in MAP. It is? Okay, it's in MAP now. That is different than the Chapter 4 Mastery. The Chapter 4 Mastery we corrected together. There's a video on my YouTube about it. The Chapter 4 follow-up you're doing on your own, like outside of class. You can do it with each other or whatever. But that follow-up is also a mastery assignment. But it was a take-home mastery. If you need help, I'm happy to help you with it, but we're not working on it during class. 512 was homework last week, and it was due last week. Like on Thursday, I think. That is in MAP now. 521 is due today, and it's going in MAP like today, probably this evening. If I'm slow, it'll go in tomorrow morning. Like if I don't get my grading wrapped up this evening, I'll finish it in the morning and get it turned in then. So the first thing we're doing today, because almost everybody has one of these, is we're going to talk about the mini mastery, the Chapter 5 mini mastery. Then we'll look at 522 homework, take any questions from that, and then we'll get into a lesson. So I got to double check if anyone's missing the mini mastery. Can anyone not get back a mini mastery, and you're not Chloe, Robert, or Vera?
Are we special?
Of course you're special, Chloe. So Avery and Stella. Avery and Stella, it looks like you need copies of this because you were probably not here when we took it. Are Avery or Stella here? Hey, look, both of you, although you didn't move at all. When I said Avery and Stella. Don't get out of your seat or anything. So, I was thinking about how to review this mastery, and I thought it might be beneficial. And this worked out really well this morning because I could just show the papers and they didn't belong to anyone. But I think it's going to work out even better right now because if these people are willing to, they might talk us through how they solved it. You have some classmates that totally mastered this, and I was debating on just having people work in small group and share their answers, but it's sometimes really beneficial to see different ways of doing things. So in number 1, so guys, we're fixing this right now. If you have a progressing, you're going to be turning it back in. So either separate sheet of paper or very obvious corrections. Like if you had a pen or something, but I would just do separate piece of paper if I was you. One way that we can do this is just using the decimal form of 20%, which is 0.20. And we could just do the math like in our calculator. And I shouldn't say just do the math, but I'm saying I'm not asking you to think really hard. I'm asking you to say, 20% is 0.2. We can do 20% of something this way. Somebody else here showed the 10% method. So here, if we find 10% of it and then multiply by 2. But I got another way that will always work. And this is my work. Guys, if you know the 100%, and you guys, you should be writing something down unless you got this right. If you know the 100%, we can build a proportion. You guys got them right. Don't worry about it. You can build a proportion. And what we've mainly been doing is the 10% rule or trick or whatever you want to say. But, you can do that with any amount of percent. So, guys, if you have 100% or any percent, I can drop back down to 1%. How do I go from 100 down to 1, divide by 100. If we do that on top, that tells me 1% is 23 cents. 0.23. You probably need one of these too, Amanda. My grade sheet is messed up because you're in a different class today. I'm going to need to print one because I did not print enough extras of this. Then, from 1%, we can get up to any other percent that we want. So, from 1 to 20, this would tell us the discount, and then I could subtract it from my whole price. Or, some people, a couple of you said, oh, well, if it's 20% off, I'm going to end up paying 80%. Sorry guys, I'm trying to print this real quick for Amanda. Because I'm goofed up. Well, I mean, this is everything you really need to see for number 1. Your final sale price is $18.40. But guys, I gotta tell you, I was surprised at the results of this test. We should be better than this at percent at this point. So if this still doesn't make sense, you have to ask me to explain it again. Like, you need to fight for, like, you understanding. Right? You got to push for that. So, like, I'll pick on Peyton because she's in the back of the room, but Peyton can easily just sit there and not ask questions and just chill. And if she didn't understand this problem, I don't know if she now understands it or not. Pretty sure Peyton got this one right. But, like, if you don't ask, and I have this up here, and you're looking at this and you're like, I don't know what that means. It's your job to say, hey, no, explain that again. Try again, Mr. Hudson. Like, good try, but it didn't work. You can tell me that I failed, the F word. You can tell me that I failed at explaining it. I'll try again. Does anyone need more explanation about this problem? Phoebe? I'll show it another way, right? I'm not going to re-explain it the same way. If you're allowed to use a calculator, which we almost always are, percent means out of 100. So 20% is 20 out of 100, or 20 divided by 100. So that tells me 0.2. Now, this doesn't directly say 20% of, but we know that we're doing 20% of something, right? Because we're trying to find out the discount on the book. So the 20% of is of $23. So if I do 0.2 of, right, times 23, tells me 4.6. This is the discount amount. That's like dollars, right? We did 20%, 0.2, times 23, and we got 4.6. So now we can't stop there because that's our discount amount. We got to take that as a discount and do 23 minus that 4.6, which gets me 18.4, which is really $18.40. You write back, run into the printer. Actually, Robert, do you want to run to the printer for me? Any chance? There should be 2 papers sitting on the right printer.
They're math papers.
They're math papers. I know, right? Did that help at all? Anyone got another way to explain this? Because sometimes me doing it isn't like, oh, the number line models that we did. That's the other way. So if I set up one of our number line models and say $23 is 100%, And I can think about splitting it up into 10 pieces like we did in class. This would be 5 and 5. So I have 10 pieces here. Practice. Each of those would be 10%. We talked in class about how do I get from 100% to 10%. We divide by 10. So in my calculator, we take the price and divide it by 10.
Did you not print it to the family room printer?
It should be the right one. The one on the right. It should be there. I'll print another one.
I'll go check. No, Robert's going.
It's okay if I print an extra one. And if it doesn't come out, it probably needs paper on the right-hand side. So you can go if you want, Sophia, to double check it. Probably needs paper fed on the right-hand side. 2.3 is 10%. Does that make sense? How we got to 2.3 being I can't do a shrug. I need a yes or a no. So from 100% to 10%, we would divide by 10 to get there. Does that make sense? So we did 23 divided by 10. So you're with me there? So then to figure out 20%, well, how does 20% compare to 10%? We would double it, right? So take your 2.3 and double it. We get 4.6. You still with me? That is the amount that they're going to take off of the price. So then I just take the original price, take the 4.6 off, and we're left with what we have left to pay, 18.4. In number 2, most of us got number 2 correct. If we read it correctly, if 10% is $450, what is our 100%? It'd be 4,500. Anyone need to see number 2 again? Like in a different way or anything? Number 3, most of us, actually some of us didn't even show any work, which was okay for this one. Most of us wrote out something like this. 50% times 7 is 350. Or some of you said, oh, well, that's half. So what's half of 7? Or some of you did 7 divided by 2. All of these get us to 350. Now, if you accidentally did 7 divided by 0.5 and you accidentally got an answer of 14, I don't need a hole punch. If you want, there's a hole puncher by Landon. You just did the math wrong. If we're doing half, it's half of, right? We're multiplying. Lucy, you good? Okay, just checking, because no offense, but I think I'm better at this than Peyton. 4 got almost everybody. 4 got almost everybody, and there's no reason that it did that. Guys, I'll just be honest with you. There's no reason that we all missed number 4. Hey, 0. Can we not draw on our hands? Because it makes me feel like you're just like not caring about what we're doing. It hurts my feelings, kind of, to be quite honest. When we go to calculate a percent, and guys, if you missed this problem, you need to write this down right now. To find a percent, we do part divided by whole. We need to do a division. Part divided by whole. Then we're going to need to do times 100. But this is the most critical thing, is setting up this division. So when we look at MC Craft's discount, they changed their price from $6 down to $5. How much did they change their price by? $1. Right? 6 minus 5. They went down by $1. What was the price originally? 6. 1 divided by 6 comes out to be a kind of gross number. Then to make it a percent, we got to do times 100. So make sure that you have this written on your paper somewhere. This converts it into a percent. That is how we can put the percent sign on our number. So 16.6 repeating. Or, guys, if you set up a proportion, how does 1/6 compare to something over 100%? We'd multiply by 16.6 here. Do the same on top. That's how we get 16.6. So the final question of would you include this on your poster, it's kind of a weird number. So if I was making the poster, I would probably just say like, now only $5. Like, I don't know that I would include 16.6% discount. It sounds weird, right? To say 16.6%. It's not as normal as saying like 30% off, 50% off, right? It's not like a nice percent. Questions on anything from the front? Anything from the front? Some of us, I think, need to ask more questions during the homework because we're going to have a probability mini mastery next week. Number 5, I think everybody got, almost everybody. Yeah, almost everybody. Some of us skipped it because we didn't have time. If the 2 minutes is the 25%, how do I get to 100%? And we do the same on top. Six, A and B are the exact same as number 4. Hey, Ava, same request I made to 0. Can you not draw on yourself during my class because it just kind of hurts my feelings? And I don't think we mastered this test, so I think you maybe should be listening right now. If I go to the Home Depot and I save $35 off $175, part whole, part whole, part whole, part divides by whole and gets 0.2. But that's not a percent, that's a decimal. So we do times 100 to get to 20%. Questions? But in reality, it's hard to spend a certain amount at Home Depot. So if I end up getting $35 off of $233, what is that percent savings? Hint, it'll be less percent because I spent more total money, so the number on bottom will be more. If this is corrected and ready to turn back in now, you can. Otherwise, turn it in later at some point. Take like 30 seconds to turn stuff in if you need to, but then get out 522. I'm not doing B for you guys. You can do it on your own. You can come get help from me. I am not doing it for you because that was one of the things that I need to see if you can do on your own. So it's going to solve exactly like A, right? So I couldn't even really hear who asked about B. It's going to solve exactly like A, except instead of spending $175, I spent $233 before the coupon. Phoebe, did you hear me? Did you hear me? Okay. Did you hear what I just said? Please make sure you listen after you ask a question. B is going to solve exactly like A, except instead of spending $175, I spent $233. Just change the 175 into a 233, but show your work. 521, we've checked a bunch. It's in the videos. We are in 522. Guys, I'm going to tell you, some of you are not reading. And I am pretty sure that you know how to read. Like, I'm pretty confident you know how to read. I think like 3rd or 4th grade made some sort of guarantee that you know how to read. But in 38, the instructions that you were supposed to read, assuming you know how to read, said compare the games with each other. You're not just saying, I picked this game, I like it better. You're comparing them mathematically. What I mean is your work should look something like this. Guys, this is literally my paper from solving this with people. I didn't do this just for fun. Like, this is what it looks like to think through math like this. So, prime numbers, I had to look up prime numbers, right? We keep looking up prime numbers. Look them up if you want. There are 8 prime numbers between 1 and 20. Something somebody asked me about, 21 to 40 still has 20 numbers. Guys, right here, 21 to 40 still has 20 numbers. Because if I start counting at 21 and I stop counting at 40, guys, this is kind of tricky. People think this is 19. It's still 20. Because you start counting at, sorry, I don't know why my camera won't. You start counting at 21 and you stop counting at 40, you have 20 numbers that you counted. Come on. Are you kidding? Come on. There we go. So, in A, game 1 is better. Game 1 is better. In B, they're actually equal. Because 4 out of 20 compared to 8 out of 40, they're actually equal. And in C, I'm not finishing it for you. Multiples of 7, 7, 14, 21, 28, 35, I had to write them down. It's easier for me if I write them down. Multiples of 6, 6, 12, 18, 24. The tricky part here is their denominators are not the same. Our denominators are not the same, and they don't actually get along very nice. So what would we need to do to compare them? Either common denominators, or, guys, can I do 5 divided by 40? Yeah, I can turn this into a decimal. 5 divided by 40, hey-oh, this is 0.125, or about 12%. Right, 0.1. I could turn this into a decimal also and compare them. Actually, I think you might be able to do this in your head. What would this be over 100? What would this be over 100? You can probably figure that out. In 39, you should have a probability for each part of the problem. And D asks you how you did it. Guys, if you write answers will vary, you're just going to make me laugh and get a check minus on your homework. Answers will vary means I'm looking for what you wrote. Phoebe? Sorry, I couldn't tell if you were raising your hand or not. So in 39, multiple of 3 or 7. So I got to think of the multiples of 3 and the multiples of 7. So I'm thinking of 3, 6, 9, 12, 15, 18, and 7, 14. That's it, because it's 1 through 20. So 1, 2, 3, 4, 5, 6, 7, 8. That's how we get 8 out of 20. We add them together. Right? Multiples of 3 or multiple of 7. All of these numbers would be a good thing. Part B. How many of our numbers between 1 and 20 are even? 10 of them. How many of them are odd? 10 of them. Wait, even or odd, is there any other type of number? No, every number is even or odd, even 0. 0's even, we talked about that. So we get 20 over 20. It's 1 or 100%. That'd be a really silly game. Somebody says, you want to play a game? I win if I get an even or an odd number. Otherwise, you lose.
I could tell my sister.
100%.
What is this decimal?
Prime or 1. Guys, we already talked about this. How many prime numbers are there between 1 and 20? 8. We did it up here. So then add the 1, 9 out of 20. And then you got to talk about how you did it. You got to write me something in D. Questions. 40's 80%. I got to see some work. You got to have some work there, or else I assume you just copied answers. Lucy. On 40? Thank you for asking. So the rainfall, they tell us, that happened prior to April, or like between January and April, is 2.4 inches. This is another part divided by whole, right? Because I'm looking for a percent. Part divided by whole. So grab your calculator. The part they gave us, 2.4 divided by the whole, 0.2. So if I set up, I don't really like writing in red. It feels too intense. 2.4 over 12 equals 0.2. But then we got to do the times 100. Times 100. That moves my decimal twice, right? So there, and then I got to add a 0. So that's really 20%. Guys, this is a complement situation. How much more percent do I need to get to all of it? 80. Guys, because it says what percentage of annual rainfall fell after April. So that's what's left. So 80% is left to fall. 80% is left to fall. And guys, people have to pay attention to this to see, like, will there be enough water? Right, like out west in places that can have droughts. They got to pay attention to how much of the rain they've already gotten, how much they need to try to keep, like, in their water supply. On the back. That's a blank back. 27, 12, 6, 61. I'll do these if you want, but I got to switch around my binder.
Eve Moore, please stop by the office for a message. Eve Moore, please stop by the office for a message. Thank you.
If 41 just has answers, you better believe you're getting a check minus. Your 41 should look something like this. I'm not doing any other parts for you. When we substitute or replace or whatever they tell us, you're just filling in. Where you saw X, you replace it with a 3. And then you do the math.
What's the area
30. Oh, I actually have it written right here. Base times height. But you could look it up. Guys, Google your area formulas. We had this amazing couple of years when, like, students were allowed to use Chromebooks and everything else, and they would just Google things immediately. And now it's like you guys have forgotten that you can Google anything, like area of parallelogram. What's up, Mrs. Goldring? Right? I guess, if you must. So, guys, if you turn in a homework that you didn't graph a shape, it's a check minus. Right? Like, I'm checking to see, did you actually solve these problems? 0. Yes. Those two are the same thing. So x to the second power is another way to say x squared. I think what you're trying to double check is x squared means multiply x by itself. So like in B, I'll go ahead and start B for you guys. B would write out like this. Who, what, Mumble McGee? Well, that's because you haven't worked much with them. Hence why we're working with them more now. The little number tells you how many of the base you'll have. So, what happened over here? Hey guys, if you're like 0 and you're like, yeah, I haven't worked with powers much, you should be listening right now. If I do 3 squared, that is 3 times 3, which is how we get the 9. Do not think it means 3 times 2. That is not what it means. It is 3 times 3. So over here, the tricky part is what's negative 2 times negative 2? Positive 4. This would actually be positive 4. So be careful on that one. 42 is graphing. I'm not going to, I can't really do it for you. I mean, that's what it looks like, but you just need to draw your axes on your paper. And guys, if I had somebody ask me and I said, of course, why would I say no to this? Especially when you're graphing on something like this, you can use highlighters or something to make your X and your Y axes, but double check what points you need to graph before you start drawing your graph. My X needs to go out to negative 10. So I need a bunch of negative X space, right? I need a bunch of space before I ever draw my axis, right? So I could probably put my axes here. That would probably be safe. And I bet I can get out to negative 10 because that's the furthest X that I have. And my Y's aren't crazy. My Y's are pretty manageable.
Excuse me, Phoenix. Could I have Sophia Borges to the office? Sophia, please come to the office. Thank you.
All right, moving on. We got to chat about the lesson real quick because I only got 10 minutes left, not even. I know. I want you to make your paper look like this. Your graph paper. So it's 5.2.3. We're going to look at coin 1, coin 2, and who is going to be the dishwasher. Chris and Rachel are fighting about doing the dishes. They're brother and sister, right? So they devise a plan for who's going to wash the dishes. They're going to flip, each of them are going to flip a coin. If the results of the coins match, Chris will do the dishes. If they don't match, Rachel will do the dishes. I want you and your team to list out all of the possibilities here and then who would be washing the dishes. Is this a fair solution to their problem of who would wash the dishes? Actually, Ongo, you probably won't need your computer. I don't know that we'll have time to get to that point where I was going to have you guys use your computers. So you can maybe put that away. I don't care, but you probably could put it away. Yeah. You could leave it, but I would like you to try to graph it in the right place so that I can see that you know X and Y correctly.
Yeah. I graphed mine in the wrong section. I graphed it in the top.
All right, you guys don't sound like you want to talk very much with each other, so we'll all talk together. Angel, when I flip a coin, what are the results possible? Heads and tails. So coin 1, if it comes up with a heads and coin 2 comes up with a tails, do they match? No. If they don't match, who's doing the dishes? Rachel. Go ahead. Daniel, can you give me another result here? Heads, heads. And Chris would do the dishes on heads, heads, right? Same with tails, tails. Vera, can you give me another result here? Tails, heads is not the same as heads, tails, right? Like we talked about with dice, a 2 and a 5 is different than a 5 and a 2. They both make 7, but they're different results. So both of these make Rachel do the dishes, but they are different results. Does that make sense? Now, another way that we could show this is a two-way table, and you don't have to copy this. I just want to show it to you guys really quickly. A two-way table is a nice way to organize information.
Excuse me, Phoenix. I need Katerina Gadiba to the office, and also Sophia Borges. Thank you.
So I called these coins 1 and coin 2. Then on heads and heads, who's doing the dishes? Chris, right? On tails and tails, who's doing the dishes? Chris. Heads, tails, Rachel. Tails, heads, Rachel. Right? So we can see that even in this situation, both of them have 2 chances to do the dishes and 2 chances to not do the dishes. What we're going to start with tomorrow, and what you could go ahead and start talking about today if you want to, because you have 2 minutes left, is if we want to try to make one of these for rock, paper, scissors. How can we make one of these tables for rock, paper, scissors to analyze if it is a fair game? I still got a couple minutes left. We could say, like, man, who should I play rock, paper, scissors against? Probably, no, because the other 7th grade math teacher, let's go Hudson versus Smith. Hudson versus Smith. Hudson versus Smith. Because I'm going to make a table in here. I'm going to make a table, and in the table, I'm going to say who wins. If you haven't played rock, paper, scissors before, rock beats scissors because rock blunts scissors. Scissors beats paper because scissors cuts through paper, and paper beats rock because paper can wrap up a rock. Alejandro, rock. So, that's our Mexican rock. So, if I have choices rock, paper, scissors, and Smith has choices rock, paper, scissors, we're going to analyze what happens on these different throws, right? When you play rock, paper, scissors, we talk about it as like a throw. You throw your result, like whatever. It's called a throw. It's like there is a legit rock, paper, scissors like national competition. It's called a throw. We will pick this up right here tomorrow. Have a wonderful rest of your day. Turn in your work. Turn in 512, 521. Chapter 4, follow-up. Chapter 5, mini-mastery corrections. A ton of stuff. Turn it all in. Hi, Mallory.
Hi, I wanted help.
Give me a second to at least stop the video.